there. I just want to say that, first off, I'm going to be sort of describing some similar conclusions that Sue brought up, although our test data is different and our tools that we're using are different. You'll hear some similar conclusions at the end. So I am the managing editor of AATA Online, which is an abstracting and indexing database for the conservation and preservation of material culture. My background is in monograph cataloging, archiving, and editing. I'm not a systems librarian, nor do I have a background in computing, but these machine learning tools and artificial intelligence are becoming prevalent enough that librarians can potentially utilize and manage them with the help of IT staff. The question then becomes, do any of the available tools fit the needs of a particular library or cataloging unit? Can they be adapted, and is it worth the effort? I'm going to describe AATA's testing of machine learning tools for the indexing part of our workflow, how this workflow has evolved, and my opinions on the usefulness of these tools. So AATA, this is the landing page, and I didn't even attempt to go live with this stuff, having done this in LA, was formerly titled the Art and Archaeology Technical Abstracts. It has been in continuous publication since 1932 and was founded by conservators and curators known as the Monuments Men. I don't know if any of you saw the George Clooney movie. Those men founded AATA. They worked at Harvard University's Fogg Art Museum, which was AATA's first publisher. AATA had several other publishers before the Getty Conservation Institute, and I'm going to refer to it as GCI, took it over in 1985, shortly after GCI was founded. GCI transformed AATA from a print publication to an online open access publication in 2002. The two most labor-intensive parts of AATA's workflow are the writing and copy editing of abstracts or summaries, so really like a 520 note within a MARC record, for articles that do not have any, and generating index terms for the abstracts. We have a staff of 3 people who work on this project, including me, and about 30 paid contractors who help with this editing and indexing work, most of whom are conservators working in the field or who have special language skills. AATA's indexing work throughout its 92-year history has been applied by hand, of course. When we were still in print and space was limited, only the most 4 or 5 relevant terms were used. After we became an online publication, the index terms were no longer limited in quantity. In an odd sort of way, the indexing became more laborious when no limits were placed. And this is an article, a record for an article from a Spanish journal that I have up here. And it has 10 or 11 terms, as you can see. AATA uses and contributes to the Getty Research Institute's vocabularies, of which the Art and Architecture Thesaurus, which is known as AAT, and we are AATA, so I hope that I can keep those distinctions up for you, is the most important knowledge organization system of the Getty vocabularies. So it's really the subjects. Many of the conservation and preservation terms in the thesaurus were submitted by AATA, and staff continues to submit and revise terms with literary warrants in accordance with the conservation field. Of the more than 13,000 index terms used in AATA, no more than 300 are local terms that are not in AAT for various reasons, mostly because AAT does not facet does not compound their headings, and we need some compound terms in some cases because that's what the field wants. Since AAT uses linked open data, and I'm glad you mentioned that, AATA has the possibility to experiment with machine learning tools. So machine learning is a subset of artificial intelligence that involves training algorithms with large data sets. The algorithms can perform tasks without instructions, such as suggesting relevant index terms. I'm going to describe AATA's testing of two machine learning tools, one which we refer to as the predictor, and the other is called ANIF. And I want to emphasize that I really think of these as tools, something that can aid people in their work, and they become much less scary when you think of them in that context. In 2020, AATA changed its user interface to Ex Libris Primo, an interface used by thousands of academic libraries. Shortly after moving to the new user interface, and I'm sorry, I have terrible jet lag. I'm sorry if I sound like a drunken sailor sometimes. A contractor and former AATA staff member was hired to work on a specific cleanup project involving AATA's personal name authority, so an authority section of what we do. Toward the end of the contractor's work in 2021, he became interested in machine learning and wanted to learn more about it. Since he had access to AATA's authority data through Getty's VPN for his contract work, he extracted AATA's over 13,000 index terms and more than 10,000 bibliographic records to train a Python script to predict or suggest index terms using the titles and the abstracts, or summaries, you can refer to them, of the records. The algorithm then learned what might be relevant for, what terms might be relevant based on AATA's past term usage. The contractor did not ask me if he could create this tool because he didn't know if it would work. But he figured it out and he presented it to me in December 2021. The files he sent included a Python script, two CSV files, one with AATA's index terms and the other with the bibliographic records that were used to train the model, and instructions on how to operate the script. Once it was installed, we were pleasantly surprised that it produced results. It was one of those tools that you didn't know you need until you have it, and best of all, it was free. To run the script, the title and abstract of an article are put into an Excel spreadsheet, just like this, and one runs a series of commands at the command prompt. Does anybody remember the command prompt? Then a new spreadsheet is output with the term suggestions, which are all the way over on the right. AATA's use of abstracts provides the tool with more text from which it can draw out key concepts from the article. Typical bibliographic records don't have abstracts or summaries, which makes experimenting with these tools more complicated for a library. One must use a combination of the title fields or other bits of metadata, such as note fields. Additionally, most bibliographic records in the US use Library of Congress, as Sue pointed out, of which the subdivisions, as she also pointed out, can be difficult to replicate in a machine learning environment. AATA includes many articles with abstracts by authors whose native language is not English, such as that Spanish record that I had up earlier. Frequently, and I'm not saying that one was, but we deal with a lot of Chinese, Czech. We deal with articles from all over the world, Hungarian, Albanian, and you could tell when they're putting them through Google Translate and you're just getting a really funky abstract. So when we can't really use those for testing tools like these, because it would be you would get faulty results and it would be like a garbage in, garbage out scenario. So we do a lot of editing work to clean those up So anyway, we can't take a new record, put it into the system with the abstract as is, and then expect to get something out. About 6 years ago, I asked our editorial board to help devise a list of publications that have good quality English articles and abstract that could be published immediately without copy editing. This set of 54 journal titles was an obvious choice to use for testing automatic indexing. AATA staff's preliminary tests in early 2022, so just about 2 years ago, suggested that this more or less in-house tool was about 70% accurate. During this testing period, the predictor was occasionally suggesting irrelevant terms, in fact, inappropriate and sometimes downright strange. This prompted us to retrain the model with terms that had been used at least 5 times, which led to better accuracy, but also let open the possibility that a very relevant term wasn't being suggested. Last fall, 2023, almost 2 years after AATA was given the tool, we were finally able to create a project to more rigorously test and start devising a workflow for automatic indexing. As part of this testing phase, we hired a part-time library science student to create bibliographic records in the MARC format from our list of approved journal titles, as well as generate index terms. The predictor was installed on all AATA computers and was run on each desktop. After the bulk of the metadata was entered in a new MARC record using Ex Libris's ALMA platform, the intern generated terms using the predictor tool, and the suggested terms were input in 650 fields. AATA staff reviewed the records and notified the intern which terms should be subtracted and added. Analysis of the results of this more stringent test showed that the tool was occasionally 90 to 100% accurate, but was usually closer to only 50%. Now, in this example above from the predictor, the terms that are highlighted in blue are irrelevant terms. So that's like half right there. But we tested many more records than just this one. At the end of 2023, I discovered a tool by the name of ANIF, an open source indexing tool that uses machine learning to generate terms. ANIF has a number of distinct advantages. It is open source. It was developed and is supported by the Finnish National Library. It has a user community. It has a better user interface, and it can be configured for higher accuracy. And our IT team could potentially install it on Getty servers, from where it could be run on individual desktops. ANIF also uses Python, like the predictor, which is a very common programming language, not that I know it, but it's common, and is loaded with various models. So this is like the demo tool if you go to the ANIF website. And you can select any one of these demos on the side. I mean, obviously, most of us would probably select English instead of Finnish or Swedish. But you would get a different result if you use the MLLM versus the Omikuji. So one could experiment, and we did experiment with this demo tool with its provided vocabularies and models, and it suggested very applicable yet general terms. If you're a big academic library, it might work well. I could see it being used for bibliographic records with publishers' descriptions in 520 note fields, or archival finding aids with scope notes. But ANIF's available vocabularies do not provide the granularity needed for a specialized subject. At least it doesn't for art conservation. If one desires more precision in their subject headings, then one must train the model with a preferred or local vocabulary, which is what we did. And fortunately, ANIF is designed to accept other vocabularies, but it does take time, effort, and technical support to install them. And installing ANIF was not a completely easy task. We hired a second MLIS intern that started this past January to help test the predictor and install ANIF, which took about 2 months of on and off work. It might have taken less time if we had more support from our Getty Digital staff, but we did have some, or else we couldn't have installed it at all. So our Getty Digital team extracted new sets of training data in CSV and tab-delimited formats, found about 100 subject authority records in AATA that we had to clean up, which was a surprise to us, and which, careful when you do work, it just may create more work. So we cleaned those up, and then they also installed on two computers what they refer to as a virtual machine. So at the moment, we have been running ANIF on individual desktops, but it would work better if we could run it from a Getty server, which we are in the process of making a request. It's a whole big deal. It's a whole big process. But anyway, that's in process. For training the ANIF model, Getty Digital extracted the more than 13,000 index terms that AATA uses and over 90,000 bibliographic records from our database. So this is like 2/3 of our database. A much larger set than was used for the predictor. ANIF was operational it was either April or May, and as you can see, it has a very user-friendly interface, and you can see it's loaded with the AATA vocabulary that we're using. And all one needs to do is just copy and paste the title and the abstract into that large box there, and the title's on the first line, and then the abstract is everything else. And for testing, I used a GCI staff member's article, which I knew had good English. So then you click Get Suggestions, and you instantly get suggestions, and we have it set to 10 terms because we really don't want more than that. We want it to be as precise as possible. So, and for this test right here for ANIF, I'm using the same bibliographic record as I used for the predictor. So which of the two tools is better? Comparing them, sometimes we notice that they suggested very similar, if not the same terms, but for other abstracts, the terms were quite different, such as in this case, if you compare them side by side. So the predictor, everything in orange is not relevant, and for ANIF, it only had one term that wasn't relevant, that's in orange. And then the final results, the green term actually was suggested by the predictor and was relevant. And then the yellow terms were very relevant to the article. They were not in the abstract. And the author who sits down the hall from me, she was kind of embarrassed about it. But I updated the abstract for her. So from the results of our tests, because we did more testing, it wasn't just this record, the ANIF model as is was about 60% accurate overall in comparison to the predictor, which was only about 50% accurate. Additionally, ANIF occasionally suggested terms that were more creative and weren't in the abstract but were a major part of the article. Given these results, we decided to archive the predictor and move forward with ANIF. And the contractor who made the predictor, he wasn't surprised that his tool wasn't as accurate and was just happy that it led us to something else. He was just really playing around. Now, I'm just going to show you one more test of ANIF. I'm using the article immediately following the previous one. It's a book of conference proceedings on conserving mostly plastic items. And the topic of this article is the conservation of a work by German artist Dorothy Goltz. And the artwork contains silicone rubber and phenolic foam. So, we press Get Suggestions. We have the suggestions over here. And here's the comparison of what the final is, and it really struggled with this one. So silicone rubber is all it really needed. Rubber is too general, and it was like throwing darts to hit the board and get anything when it suggested the other terms, but in particular, it suggested silicon, which is an element and is like, has nothing to do with this. But it was just like misreading, you know, because it came very close to it. And then also what was very disappointing, it missed phenolic resin and artist intent, which were also part of the article, said slightly differently, but it should have really picked it up. So in essence, these tools need human review. They really do at the moment. We are keenly interested in optimizing ANF to achieve better than 60% results. Currently, AATA is using the first algorithm in the ANF tutorial called TF-IDF, or term frequency inverse document frequency, which is a weighting system that assigns a weight to each word in a document based on term frequency. There are other algorithms, as I showed you before, that we have yet to experiment to generate better outcomes, and the staff of the Finnish National Library has suggested using the MLL, which is Maui-like lexical matching, or Omikuji. So those two we're going to try out. So it's going to require the help of Getty Digital, and we are in the beginning stages of doing this work, but first thing is we really need to get it installed properly. So, you know, first things first, we're working on it. So far, AATA's staff have stringently reviewed the approximately 500 bibliographic records that were created with index terms generated by the predictor and ANF. We would rather not continue this practice, but no matter how much training, machine training these tools have, they seem to sometimes make suggestions that are irrelevant or plain wrong. We are in the process of developing best practices for using this tool in light of its fallibility, with the following goals in mind. Determine the types of articles and abstracts in our workflow that can be indexed with machine learning. We think we can do a lot more than just these 54 titles. Devise procedures for term review and decide who runs the tool and picks the final terms. So in other words, you probably want to do this at an expert level, who does the final selection. Optimize the ANF algorithm to obtain better results, maybe within the 70 to 80% accuracy range, and finish writing documentation. We do have some documentation for installing. In the future, I could see AATA using automatic indexing for many, if not all, bibliographic records. However, they would have to be copy edited first. We have not had the time to test this workflow yet. For now, we are confining the use of ANF to the approved list of journal titles, with library science students running the program at the point of bibliographic record entry, then reviewing and revising the terms afterwards. For us and our small 3-person staff, this seems like the best approach for now. I mean, until we can test it more and have it installed, it's hard to see beyond what we're doing right now. And relying on interns is a process that might be viable in the long run, but I think we need some constraints to ensure that this workflow augments and is not more effort than indexing by hand. And that's kind of the key. At what point do you decide to move forward with these tools, or just say, forget this and we can do it faster with an expert. So, how to avoid pitfalls? The biggest pitfall I see in using AI tools is assuming that AI and machine learning will make subject analysis or any library workflow easy. These tools can potentially make certain aspects easier, but the tools must be tested, fed accurate data, and be targeted for effective outcomes, as well as have a well-defined purpose, documentation, and software development to make them useful, or they will be inefficient, inaccurate, time-consuming, and potentially expensive. Even though AATA has more configuration to do, I think ANF will be useful to streamline part of our indexing work under certain conditions. If you are part of a small library, and most art libraries are small, I would suggest there's no harm in waiting for more tools to be developed in the future.